Hello class, welcome to 1440 section 6.6, area between curves. Okay, let me turn off this overhead light because I don't like that reflection. Here's a picture of my dog and I'll be right with you. Okay, so find the area of the region completely enclosed by the graphs of f of x equals x plus 2 and g of x equals x squared minus 4. So whenever you want to find the area completely enclosed by two graphs, it's always recommended to graph the function. So for the solution, so this is example, EX means example, and we're going to try this problem, and here comes the solution. Let's graph the functions, and then we want to find the points of intersection. So that way we get the complete enclosure from x equals something to x equals something. Okay, so here we go. By the way, I'm holding this camera horizontally because a student wrote saying that the video was too small. I don't know, something like that. So maybe this will help. But if it turns out that this is going to be off kilter, I apologize. Alrighty, so here we go. Let's graph. First I'll graph f of x equals x plus 2. So f of x is the same thing as y. So I'm going to write y equals x plus 2. And that's just going to be a line. And then I also want to graph y equals x squared minus 4. G of x is the same thing as y, output. So y equals x squared minus 4. And, if you forget exactly what these graphs look like, just make an xy table of values. 2 points determine a line. This is going to be a parabola because it's a second degree function. So, you would probably need 4 or 5 points. But I'll do it more quickly. So I'm going to go like this. Make a Cartesian plane. X-axis, y-axis. So my y-intercept, if I let x equal 0, my y-intercept is 2. So go up 2 on the y-axis, and that point will be on the graph. And then the slope is 1, because the number in front of x is 1. So this is like y equals mx plus b. If the slope is 1, that means I rise 1 and run 1, because rise over run would be 1. So I'll do that right here. And it's just a rough sketch. So there's my line, y equals x plus 2. And now for the parabola, I know y equals x squared is just going to be right at the origin, the vertex. But this minus 4 means that we're going to drop the parabola 4 units down. It's a vertical shift down. So go down 4 units. 1, 2, 3, 4. And then we draw our parabola. And here are the key points, the points of intersection. Right here and there. So I want to figure out what are these x values. Because the area that's completely enclosed, I'll shade right here. That's the area we're looking for, the area between the two curves. So what is this x value right here? And what is this x value right there? So to find these points of intersection, what you want to do is solve the system of equations. Solve. So let's solve this system of equations. And I'm going to write y equals x plus 2, y equals x squared minus 4. So to solve this system of equations, I think the best way to do it is by substitution. So in place of this y, I'm going to write x plus 2. Because another name, y is x plus 2. So in place of this y, let's write x plus 2. So x plus 2 is equal to x squared minus 4. X plus 2 equals x squared minus 4. So in place of this y, I wrote x plus 2. So looking at the bottom equation, instead of writing y, write x plus 2 equals x squared minus 4. Let's solve this equation for x now. And that will give me the 2x values I'm looking for. Okay, so I'm going to subtract x and 2 to each side. I want to get 0 on this side, so you could go minus x to each side, the equal sign, and then minus 2, or I'm just going to do it both at the same time. Minus x minus 2, minus x minus 2. So when I subtract x and 2 from each side, I get 0, which is always a good number. So 0 equals, and then putting this in standard form, I've got x squared minus x minus, and then minus 4 and minus 2 is a minus 6. So I'm adding the two equations up. So I've got x squared minus x minus 6. Okay, so the best way to solve this quadratic equation is to factor the right-hand side. So let's do that right now. 0 equals, it's going to be x and x in the first positions, because x times x gives me the x squared. We're multiplying to a negative, so the signs have to be different. So I'm going to write plus minus. And then what two numbers? Multiply to negative 6 and add to negative 1, because this is like a negative 1x. So minus 3 plus 2. That is how you factor that polynomial. And now by the zero factor rule, set each factor equal to 0 to get your two solutions. When does x plus 2 equal 0? When x is equal to a negative 2. When does x minus 3 equal 0? You can write it out if you want. X minus 3 equals 0. When you add 3 to each side, you get x equals 3. Or you can just do it in your head. So these are my x values. So let's look back at our picture. So this x value is going to be the smaller one, which was negative 2. You really don't have to figure out the y value, but you can easily enough. I'll just do it for fun. So you go into either one of these two equations here. It doesn't matter. Go into either one. This is a 2. So if I go into the top equation, if x is a negative 2, negative 2 plus 2 is 0. And likewise here, negative 2 all squared is 4. 4 minus 4 is also 0. Because when x is negative 2, it solves the system. Same output for each equation. Okay, so just to be thorough, I'll write negative 2 comma 0 for that point. But really, I just want to know about the x values, and what x interval we're looking for, the complete enclosure. Okay, and then for this other point, we're going to say x is 3. So this is going to be 3 comma, and notice if x is 3, 3 squared is 9, 9 minus 4 is 5. Likewise here, 3 plus 2 is 5. So if you want to, you can write 3 comma 5. Those are the points of intersection. So now we're easily halfway done with this problem. So all I'm going to do now to find that enclosed area is find the integral, because integrals will give you area. So here we go. I'm going to write area equals, and it's going to be the integral from x equals where to where? You got it, from negative 2 to 3. So you're looking at these x values from negative 2 to 3. Those are the x values. When x goes from negative 2 to 3, the entire area is enclosed. So let's write negative 2 to 3. And then to find this enclosed area, you always write the top curve minus the bottom curve. So when I look at this enclosed area, isn't the top curve the line, which is x plus 2? So let's write x plus 2, and then it's always going to be minus the bottom curve. And the bottom curve is this parabola. And because the parabola is more than one term, you must use parentheses, y. So it's going to be x plus 2 minus the expression x squared minus 4. And then let's write dx, because we're integrating with respect to x. So it's good to have good form. Okay, so before I start integrating, let us simplify this expression. So now the area is going to equal the integral from negative 2 to 3. I'm going to write x plus 2, and then distributing the minus sign so I can drop the parentheses, I get a minus x squared. And then plus 4. If you're going to make a mistake with this problem, it might be just that, forgetting to write plus 4, because what's minus a negative? Exactly. And then we can write the dx. If you want to, you can put parentheses around this integrand. Our book does that, but you don't have to. So I'll do it in the spirit of our book. So there is my integrand looking a little more simplified. But I can go one more step because the 2 and the 4 combine. And you don't have to, but I'm going to put it in standard form. So let's continue. Let's continue over here. So instead, I'm going to write the negative x squared. So I'm going to write the integral from negative 2 to 3 of negative x squared plus x plus 6 dx. So that's what I have. And now this integral doesn't look bad because this is just a polynomial. We're just going to integrate term by term because the integral of a sum is the sum of the integrals. So let's go term by term here. So this is now going to be, so again, this is called a definite integral. The first step for a definite integral is just to find an antiderivative, otherwise known as indefinite integral. And then you're going to draw the evaluation bar. And then we're going to evaluate and subtract. So the integral of the first term is going to be negative x cubed over 3. We know that by the power rule. Notice because I'm invoking the power rule of integration, I no longer write the integral sign. Do not write the integral sign when you're actually integrating. Otherwise, you're going to have to integrate again and again and again. So remember, when you integrate, drop that integral sign and also drop the corresponding dx. Okay, plus, and then what is the integral of x dx? X is like x to the first, so it's going to be plus x squared over 2. Plus, and then what is the integral of a constant? It's going to be that constant times x, so plus 6x. Remember, the derivative of 6 is 0. The derivative of a constant is 0, but we're doing integral. The integral of 6 dx is 6x. And as a check, is the derivative of this antiderivative back to the original? Yes. Now that I have my antiderivative, we draw the evaluation bar, and we're going to evaluate from x equals negative 2 to x equals 3. And when we do this evaluation and subtract, we are going to get our final answer. So let me clear the board a little bit before I continue. Here's my doggy again. Okay, so I'm just going to clear this here. Running out of room. Here's a quick math joke. What is 5q plus 5q? An algebra problem. 5q plus 5q. And the answer is 10q. You're welcome. Sounds like thank you. Okay. All right, so let's do the evaluation. And which number do I input first? You always input the top number first to get that area. So you always evaluate by inputting the top limit of integration first, and then minus, and then you input the lower limit of integration. So let's write, instead of writing negative x cubed, I'm going to write negative 3 cubed over the 3. And I'll do that over here. Negative 3 cubed. Negative 3 cubed. And notice the negative is not going to be involved with the power, because if you look at here, it's only the x is getting cubed, then you make the answer negative. So just to be thorough, I'm going to put parentheses around the 3. So it's going to be negative 3 cubed over the 3 plus, and then instead of writing x squared over 2, I'm going to write 3 squared over 2 plus, instead of writing 6x, I'm going to write 6 times 3. So we just input the 3, and now we're going to go minus, and now input negative 2's everywhere. So minus, and then, let's see, I'm going to write minus the expression. So since we have an expression coming up, use parentheses, minus the expression, and now, here we go, I'm inputting a negative 2. So now it's going to be minus the expression negative, And then in place of x, we're going to write negative 2, and then that gets cubed all over 3 plus negative 2 squared all over 2 plus 6 times a negative 2. So this is what we have. So it's minus the expression, and since the first term was negative x cubed over 2, you got to write negative, and then your x is negative 2 cubed all over 3. Okay, so from here, all we're going to do is simplify. So I'll try to do this a little more quickly. So this is now going to equal, so you got to do the power first. So 3 cubed is 27, and now it's going to be negative 27 over 3. So negative 27 over 3 plus 9 over 2 plus 18 minus the expression. And then you got to go negative 2 cubed is a negative 8, because a negative to an odd power is negative. But now, what's minus a negative 8? 8. So it's going to be 8/3 for that first term. 8/3. Remember, by order of operations, you just can't say minus a negative is a positive. You got to actually cube the negative 2 first to get the negative 8. Then minus a negative 8 is 8 over the 3 for the 8/3. Okay, and then I'm going to write plus negative 2 all squared is 4, and then 4 over 2. Or you can just write 2. I'll show my work. And then plus 6 times negative 2, that's going to be minus 12. So this is going to equal negative 27/3. Well, 3 goes into 27 9 times, but don't forget to write the negative. Plus, I'll just write 9/2. I could write 4.5 as well. Plus 18. And now, I'm just going to distribute the negative here. I could also just add, I could do the work in the parentheses first, then go minus that. Or you can just distribute the minus to clear the parentheses. I'll do it that way. Either way, you get the same answer. So I'm going to write minus 8/3, and then minus a plus is minus. 4 divided by 2 is 2. So just write minus 2, and then it's going to be plus 12. Plus 12. Okay, I'm going to underline all the numbers. I got a negative 9, the integers, negative 9, a plus 18, and a plus 12, and also a minus 2. Those are all my integers. Let's combine those integers. So negative 9 plus 18 is a positive 9, minus 2 is 7, plus 12 is 19. So this is going to equal 19. And now the only thing I have left is plus 9/2 minus 8/3. Let me write that down. Plus 9/2 minus 8/3. Okay, this is taking longer than I thought it was going to take. Sorry about that. This will be my last problem, by the way. I don't like to go too long, otherwise it gets boring. So let's get 6 as a common denominator just for the last 2 terms. So I'm going to multiply by 3 and 3. So 9/2 times 3 times 3. And then with the 8/3, I'm going to go times 2 times 2 to get an equivalent fraction. This way I get the LCD. So this is now going to equal 19 plus 27/6. And there's more than one way of doing this. Minus 16/6. So this is now going to equal... This is now going to equal 19, and then what is 27/6 minus 11/6? I'm sorry, what is 27/6 minus 16/6? And the answer is it's going to be a plus 11/6. Keep the common denominator. 27 minus 16 is 11. And then the way I would do this is I would rewrite 11/6 as a mixed number. So how many times does 6 go into 11? Let me do that over here. 11 divided by 6. 6 goes in 11 almost twice. It goes in only once with 5 left over. So as a mixed number, 11/6 is 1 5/6. Okay, so let me continue. We're almost done here. So getting back to where I was, I'm going to write this is equal to 19 plus 11/6, we just said was 1 5/6. 1 5/6. So what's 19 plus 1 5/6? Yes, you got it. 20 and 5/6. And that's my final answer. That is the area of this shaded region. And we are done. Okay, thank you. Bye-bye.